Now, as far as joints are concerned, the other part of a kinematic diagram, there's the pivot joint, and it's nothing more than just a dot at the end of a link. And it's more like a pin or some kind of a connector that would be just something that you can pivot on. The slider is another type of joint, and this is a block that would slide either on the frame, such as in this illustration, or on a link like this one. So imagine this is just a slider block just going across the surface. It's either on the frame or on a link. Now, finally, there's a piston that's involved. A piston is where you have a rod that goes inside a cylinder. And that piston can be represented this way on a complex link, or this way on the frame. And it represents the cylinder that we have and the rod. And this is the rod. Okay, so there we have then a way in which we can move the links using hydraulics. You don't have to show anything more than just a simple symbol. Now, as far as the point of interest is concerned, it has no connection because it doesn't have anything to do with the integral part of the mechanism. It's some kind of outside force. It could be an inside or an input force or the end of the operation. So if you can imagine a digger of some kind, the digger would have a scoop on it like this. And that point is a point of interest. It's not connected to anything. All the rest of the mechanism is here within the machine, but this is the point of action, and that's a point of interest, and that has to be identified. And it does not have any letter or anything on it, nor does it have a joint. And finally, when you label your diagram, you label the diagram with these three labels. One is the link, and all the links use numbers. And they're numbers in circles. So you start with 1, 2, 3, 4, so on. The number 1 is always the frame. Always the frame is number 1. Beyond that, you can choose any number you want for any part. The second are the joints. The joints, we're going to use capital letters. Now, in the beginning of the alphabet is what we'll use, starting at A, B, C, D, and so on. So as many joints as you have, you use letters. And then finally, the points of interest, they're also kind of like joints, but they're actually different because they don't joint anything. They're just at the end or the beginning of the mechanism. And in this case, we're going to use X, Y, Z. If there's any more than that, of course, you go backwards in the alphabet. So you have ways in which you can label the various parts. Now let's take a quick look at an illustration as best I could on the board here. Here we have a frame connected in 2 spots. Now, I've only used the number 1 once because it's the same frame, so therefore I don't need to label it twice. I just label it once. And then the links, there's this link here that has a piston on it. Then there's a complex link here, another piston over here, and another complex and another simple link there. So you just draw straight lines. They don't represent any real specific shape other than the fact that they should have all the links and joints on there. Now, so therefore I number the links here. And now I'm going to number the joints, or letter the joints here, starting anywhere you want to. Joints don't have to start at any one place. And every joint that you have, you label the joints around the diagram. Now, as you can see, I've shaded the complex links. And I've left the simple links open, and I've given you the illustration of the pistons. Now you can find this information on the assignment tab when you start doing your own kinematic diagrams. There's also information in the book about how you should construct it. There are examples, many examples in the book, and how they should look. My final point is this. Make sure your sketches are neat and clear. The accuracy and the neatness of your lines, the clarity of your text is very, very important in order to understand what you have done. So it's time to move on, and it's time for you to do some kinematic sketching. So good luck.